Este workshop es la tercera edición, lo estamos haciendo todos los veranos y la idea es dividirlo en dos. Primero hacemos una escuela de 2 o 3 días en donde le entregamos a los alumnos un poco las herramientas para que ellos puedan entender bien las charlas del workshop, y después llamamos a invitados, en este caso son 4, han sido 3 o 4 invitados que vienen a discutir temas que están relacionados con nuestra investigación de corte más internacional. En realidad no hay muchas instancias para los alumnos de acá de poder codearse con estos investigadores. O sea, estamos hablando, son investigadores, generalmente son súper famosos, que los invitan regularmente a dar charlas. O sea, es gente que es de peso y nosotros los podemos reunir acá, les damos como un enfoque como un poco más dirigido para los alumnos. Además tenemos la escuela donde ellos pueden aprender también un poco más de técnicas que quizás no sabían para poder seguir las charlas. En general es una instancia muy importante, creo yo, para que nuestros alumnos puedan ver lo que se está haciendo en el mundo a nivel de investigación.
We tend to, when we're in the academic environment, sort of steer people toward that academic career because it's what we know and it's, you know, very clear what that path is. But this other path of building things, it's massively enriching, and it's I would argue it leads to better science, because you can understand something on a certain level by reading papers and writing simulations, but it does not compare to the depth of understanding you have when you have built the system from the ground up and you understand all of the compromises you had to make that thing work and what needs to be done to advance it. So that's what's motivating everything here. I really think that deep ideas do come from a good understanding of a problem, and if you don't have a deep understanding of that problem, none of the ideas that you generate will be sufficient or important. So this is just a funny set of cartoons. There are things that are very different between applied science and research, and there are things that are also the same. So in general, applied scientists work with a very short time horizon, 3 months to 18 months. And you would say, well, you know, there's no interesting problem that you can think deeply about and solve in 3 months, and that's true. But if you set, as a scientist, a 3-year horizon, and then break it down into smaller chunks, and then just show steady progress every 3 months, then that's what they're looking for. And so the most of the talk, after we go through, you know, why we would do applied science versus research, most of the talk is about how to manage the science so that you can do real science in an applied setting, because it can also go very, very wrong. And the talk was basically about how to integrate science into products when you work in applied science, and why you would do applied science to begin with. And I would argue that applied science allows you another vector for influence beyond just publication. It allows you to actually build products that people will use and that will influence the way people experience the world. And it also allows you, by doing that, it allows you a greater understanding of the problem that you're trying to solve, and therefore allows you to do deeper science than you can do if you don't build the system. I think it's especially true in computer science. I think it's true in all sciences, but in computer science very often we allow ourselves to do the abstraction and write a paper because the industry has developed that way, whereas in other sciences they only build things. So I think we should go back to our science roots and build the systems that we're studying and let the two inform each other.
Today I want to talk about one particular type of knowledge or data that doesn't sit on the disk like the regular data that we're playing with, but actually sits in our heads. My head, your head, everybody's brain. And the argument is that we have a lot of knowledge, and if we could just extract all this information, we could do really interesting things. So that's what the talk today is about. And in general, this area is called crowdsourcing, or we focus on data. It's crowd data sourcing, and I'm sure you know already, or you have experience with a lot of different types of these things. Like, for instance, who is not using Wikipedia? So you're all using. So the question is, how can we learn from people? How can we effectively try to learn about things that we don't know? For instance, about, healthcare. Suppose we want to learn what are the habits of people, things, how do they treat themselves, what kind of folk medicine they are using. How can we extract this information from the crowd? And in particular, what questions should we ask and how in order to extract this information? Okay, so that's what I'm going to talk about. Yes, it was about crowdsourcing. Crowdsourcing tries to use people's knowledge, people's brain, whatever, extract the information and try to analyze it and use it just like you use information that is typically on a disk or in a database, but information that comes from people's minds for the benefit of the world. We already know, or in the way to know how to analyze information that is already digitized, but there is a lot of knowledge in people's brains that we have no access to. And this helps us to extract this and use it, and that's very important. Actually finding the way to extract the information, to make people tell you what is interesting, to find the right questions to ask people and to do it in an automatic way.